Today I wanted to do a few more problems from 7.2, just to make sure you're good with that topic. And we're getting to 7.3 and 7.4. You'll notice we're going to return to the binomial probability distributions. Remember with like the binom PDF and the binom CDF, so we're returning that. We're going to make the connection between binomial distributions and normal distributions, the bell-shaped curve. If you recall, I remember in class, Art, even you made the observation, the binomial distribution, you notice it was bell-shaped. And so they do become bell-shaped at a certain point, depending on the sample size and the actual probability of for the success of that trial on the binomial probability distribution. So anyway, the problem we were doing last dealt with the gestation period, and this was the mean. It was 266 days. Was the mean for the population. That was the mean gestation period. The standard deviation was 16 days. And we just knew, all right, this is what the image looks like. You got a 266 in the middle. This is like an X. If I went one standard deviation over to the right, we realized you had 16 of that. It was 282. And over here it was 250. But this is what the distribution was. Here's the X values. But we were doing everything with Z-scores. We were standardizing everything with Z-scores. And Z equals 0 at 266, and Z equals 1 at 282, and Z equals -1 over here at 250, right? Is that one okay how I made that image? Just using these two numbers. They said this was the distribution was approximately normal. And so we're able to make this image. And we were answering a bunch of questions. So I wanted to do a couple more with this. And this was from section 7.2. The problem we were doing was number 41, and it was on page 378. But I just wanted to continue with a few more questions. Did we get up to like a letter D? Okay, so we'll call this one E, and we'll just do another one. What's the probability? This time I'll just put P with this statement. Oh, I should do a percentile rank. I should do another percentile rank. All right. And what is the percentile rank? I should definitely do another one of those. What's the percentile rank of a gestation period that lasts? Last time, do you recall the number I used?
5, I think.
Way down here was a low 200. 230. All right, this time, everyone, I'm going to use 240. That lasts 240 days. All right. So if you ever hear these words, percentile rank, and it's dealing with a normal distribution, we did a 3-step process every time to come up with the solution. And the first step, we always made a picture. Well, your picture one, you're going to be shading from the left side, always, for percentile rank, because you're accumulating from 0%. So almost like that word right there, percentile rank, you're like, that's how I'm going to shade my picture of my bell, no matter what. Always from the left for percentile rank.
So percentile rank is always below.
That's right. Percentile rank is always below. Think less than, yeah. He's like, think. You could change the question to less than 240 days if you want. Every time you see percentile rank, you could change the wording. You could say, what's the probability that the gestation period lasts less than 240 days? You can absolutely do that. Absolutely. So I'm just going to put a line over here. When isn't 240 off to the left somewhere? And here's my 240. That's an X value. Step 2, we found the Z-score. And there's a way to do this problem without finding the Z-score, but I'll still find it. It's our first problem today, so let's still find the Z-score. The formula for Z is X minus mu over sigma. I'll put that up here just so everyone knows. Z equals X minus mu over sigma. Your data value minus your mean divided by the standard deviation. And we can calculate the Z-score for 240. And so that's the X value. The mean was 266, And the standard deviation was
16.
16. Now, if you do all this at once on a calculator, will you put parentheses around the top? Because of order of operations? Thanks. All right, let's see what we get. Negative 14? No, I'm sorry, negative 26 over
16.
what did it come out to on a calculator? Negative,
13 over 4, 13 over 8.
yeah, what's the decimal?
Negative 1.625.
Negative 1.625. All right. So now it comes to finding the actual percentage, the probability, all right, or the percentile rank. Well, these words mean the same thing, the probability, the percentile rank. If I said probability, the question would be, what's the probability that I randomly chose one woman who's pregnant and her gestation period lasts less than 240 days? Well, we always use, with our TI-8384, this normal CDF button. We just use that right there. And in here, we put our lower Z, our upper Z, the mean of Z, and the standard deviation of Z. This is what we did. Now, these two numbers are always the same thing. You can look in that image I drew right here. What's always the mean of Z?
0.
0. What's the standard deviation of Z?
1.
1. So, this is always 0 and 1. And you look at this image, you're like, well, what's the Z-score right there? The X value is 240, but the Z-score associated with that is a negative 1.625. You go, what does that really mean in real life? We're saying that a woman with a gestation period of 240 days is 1.6 standard deviations below the mean. That's what we're saying. Well, the mean was 266. So I get to put the lower Z is going to be, sometimes students make errors and they put the negative 1.625 here. That's not it. So when you look at this, lower, upper, lower's left, upper's right, you can use your hands. What's this Z value way over here? Because it's shaded, and this thing shades forever. I only shaded to here, but I mean, you're shading what?
To infinity.
To infinity that way, which is a negative infinity, true? So what's my lower Z?
Negative
Well, it's a negative infinity. The only thing is we don't have a negative infinity button, do we? So we use a drastically very high, large negative number, which is negative 1 E99. And then what's the upper score? Negative 1.625. Now, how do we do that on the calculator again? Then we do a negative 1 E99, and we'll go through it. Let's go through this again. How do I find that negative 1 E99? So when this is, I wanted to make sure we did at least a couple of these problems today before we get to the other sections. So I go in here, I'm like, okay, I go to the distribution menu, which is second bars. I hit normal CDF, and I can put negative 1. To hit that E, everyone, that means times 10 to the 99 power, I have to hit second comma. Second, then the comma. That uppercase E, it's not the lowercase E. And then I put 99. Then I put a comma, then I put negative 1.625, 0, comma 1. All right. Now, what are some acceptable answers? I could say that the percentile rank is, here's my final answer. I could say this. I am fine with that. Because what percentile is that? You can read it to me. What percentile?
5.
Yeah, it's a 5th percentile. But this is an appropriate way to answer this question. We'll say 5th, and then we'll say percentile. So I'm going to write it like that. And yes, everyone, if it was 0.055, I accept 5th or 6th percentile. But if you just want to write that, that's fine too. So is that okay with that? Awesome. Hey, and another way this question would have been asked, what's the probability if I randomly chose, pregnant woman from Anne Arundel Medical Center, that her gestation period is less than 240 days. We get that same answer, it'd be like 5% chance. Very small, but almost rare, right? Very close to being rare, 5%. We'll consider anything under 5% in this class unusual. Cool? All right, hey, so let's do another one. Let's see with this one. I'm thinking, how about negative. Right. Excellent. Here's my next question. And what's the probability that a randomly chosen woman's gestation period lasts less than 202 days. Okay. And we go through the motions, right? The first thing is I make a picture. 266 is in the middle, right?
Mm-hmm.
Where is 202 in the image?
All the way to the left.
It's over to the left. Isn't it really far though? Yeah, we're like, well, it's over to the left, but I mean, it's really far off to the left. So this is going to be an interesting answer to our question, right? I mean, you'll agree, I'm not shading much, am I? I mean, it's way over here. I'm even shading too much. I just wanted to get some yellow chalk on the board. You know, I'm shading to the left, but you know, and this thing is probably really far past here in terms of spell shape. A few standard deviations over here. This would be a wild z-score, way past -3 going to the left side. All right. Do you have an idea of the answer to this question before we do all the math? Is this going to be a high probability? Excellent. So good. Yeah. Statistically literate. You're like, this is going to be a very, very low probability this would happen. I mean, that's 202 days. You can calculate the months there. I mean, that is low, right? 30 days in a month, right? 30 times 8 is 240 days. You're like, my gosh. So we're going to get a low probability here. We're expecting that. When we do this problem, I've got my 202 over here. I'm still shading to the left, right? Mm-hmm. Is everyone okay if this time I take the shortcut?
Okay.
I am going to bypass step 2 where you had to calculate z. I could have done that. And I'm going to do all this because I just think a lot of you will prefer to do this. And I can just do my lower x value, my upper x value, the mean of x, and the standard deviation of x. So is everyone okay with this? All we're doing here is we're saving time, right? We're saving a step. I'm saying I'm just going to skip over this. So by me marking this off, I'm saying I'm going to skip this step. Because I don't feel like doing it. I could do it. But I'm going to go right to here because I know what I'm expecting, but I'm going to let the technology do the work for me. Except now I'm going to do lower x, upper x, mean of x, standard deviation of x. So now, this is not 0 anymore. What was the mean of the x's?
266.
Yeah, that's right there, that 266. See that? So I'll put it in here. Standard deviation of the x's. You can go over and look. What was it? It has to be given to you. And you can definitely do this. Please feel free to do this. We're skipping a step in our process here. Look at this. We can still use for lower x. What's the lowest? Negative what? 1e99. But what's that x right there? 202. So let's type it in our calculators. we are expecting a very, very low probability. Maybe close to 0% chance. Because we're saying this would be very unlikely, right? Tori?
So it's always 1E99.
Yep, it's always at when these things are shaded either on the left tail or on the right tail. And so Tori, if it's on the left tail, you're like, because we always do a lower and an upper. If it's shaded on this side, you're like negative 1E99 for your negative infinity and then the number. If we shade over on that side, I'll just make a quick image. If we did like a greater than, you had something over here, I'll just make up a number like 270. And it went this way, like that. You're going to use 270 and then positive 1E99 for your value. Sound good? Outstanding. So, I'll go and hit it. Second distribution, normal CDF. I'm going to type this in. So I want you to see this number. All right. Negative 1E99. That means negative 1 times 10 to the 99 power, right? Comma. 202. 266, 16. And we expect a really low number. Do you agree? So when I'm on my test, you see what's on the screen, right?
Mm-hmm.
Guess what Professor Messenger gets all the time on his tests? You ready? Final answer. This happens all the time. That's my answer. That's not right, is it?
No.
I mean, think about that answer. You're like, that, no. 1.0 is a 100% chance. This is saying the odds are 316% chance. Do you agree? You're like, then it's impossible. What did I forget? It's very important. I'll hit the lights way at the end. Someone see it? That what? E
Minus 5.
and then negative 5. Now, if you want to write that as a decimal, absolutely. What's that as a decimal?
0.40s.
You can write it like